Okay, so we're going to start understanding this half interested or more interesting lesson, right? And what we're doing here is actually, I'll just let you see it. So let me just move forward to this part here. You should remember how to do these things. So it says, examine how properties of exponents work with rational exponents, write equivalent exponential functions using different growth factors. And what do rational exponents and negative exponents mean in the context? Do the laws of exponents work with rational exponents? And how do the growth factor change if we focus on a month of exponential growth instead of a year? So reality, I'm going to go try to make sure that everybody leaves here with the understanding of these two questions here and being able to do these two things up here. So in reality, you already know your properties of exponents. They're asking, do they still work with fractional or rational exponents? The answer, I think you guys already know the answer is yes, it'll still work. You just have to understand what it actually means in that context, which kind of brings you down here. Okay. So let's continue. It says, Carlos and Clarita, the Martinez twins, have run a summer business every year for the past 5 years. Their first business, a neighborhood lemonade stand, earned a small profit that their father insisted they deposit in a savings account at the local bank. When the Martinez family moved a few months later, the twins decided to leave the money in the bank where it has been earning 5% interest annually. Carlos was reminded of the money when he found the annual bank statement they had received in the mail. Remember how Dad said we could withdraw this money from the bank when we're 20 years old? Carlos said to Clarita. We have $382.88 in that account now. I wonder how much money that will be in 5 years. Okay, so just reality here. Number one, I think all of you have experienced money. And if you don't have a savings account, you can play around with the savings account and see how that all works. When you get your first savings account, I'm just going to tell you 5% is huge, like gigantic, which seems like really, really small if you think about it. But in the world of savings accounts, that's actually a pretty hefty percentage. Okay, so Carlos calculates the value of the account 1 year at a time, and he has just finished calculating the value of the account for the first 4 years. Describe how he can find the next year's balance and record that value in the table. So I was looking at what you guys were doing, anonymize, and I was pretty impressed with some of the answers that I saw. Some of you are playing with the recording things here. Awesome. So so here you can see someone looking at the rates of change. Over here. Ooh, okay, here goes. What in the world? Where is this person getting 1.05 from? So in the chat, tell me where you're getting this 1.05 from. Where is this person getting 1.05 from? So where did this person get 1.05 from? Very good. It's all coming from the percentage. Okay, and what does that mean, Ms. Johnson? Why is it 1.05? Why is it 1.05? Okay, so someone said very wisely, one, because we have to keep the original value because we're adding the interest on top of that. So remember, we talked about this before, like you ever go in here and you're like, yes, I know how to do this, Ms. Johnson. I'm going to take that $465.39 that they have after year 4, right? And I'm going to multiply it, not divide, I'm going to multiply it by 0.05%. Now, if Carlos or Clarita or you had $465.39 and you look into the bank account the next day and you had $23, what would you say? Yay Would you say, yay, my money, it's making money? Is that what you would say? What would you say? Or here's another fantastical thing, right? What would Miss Johnson say? What would Ms. Johnson say if she put $465.39 and it's supposed to be earning 5% interest, and she looks in there the next day and it's $23.2695? Yes, I'm suing someone. Get me the manager, something, something, something. And then I realized, oh, they forgot to calculate and they forgot to put a 1 here. This 1, like one of your classmates said, is because we need to keep the, I don't know why this is mini. 1, because we need to keep the original value 0.05 because we're adding the interest on top. This word right here, key, adding. Adding it to what? Adding it to the 1. Okay, very good. I'm going to save this in my notebook because that was fantastic. Boop, boop. Okay, so that's going to be there later on for you to look at. So is that correct? $488 and like 60 something cents. So of course, yes, Ms. Johnson would be very angry if I put money in there and I did this. So when you're doing this, please think mathematically like, oh, Ms. Johnson, would she be okay with that? No, she wouldn't. She'd be like, get me your manager right now. Like, please stop talking to me. Go get me someone who can fix this. Okay. Because this is nonsense, right? I didn't ask them to take 95% of my money. I asked them to, I'm letting you borrow my money. That's basically what's happening, right? With banks. Very, very good. So if you don't have this answer on there, put it on there now. Put it on there now. When do you want me to put it on there? Right now. Put it on there right now. Okay. All right. So we're going to be moving right along. Very good. Oh, sorry. I'm talking in my accent. I'm very excited for you guys because you have the right answer. 1 and done. I love when I get to my group work. Okay. So I'm going to read the next question and then we're going to see what you guys put. Clarita thinks Carlos is silly calculating the value of the account 1 year at a time and says that he could have written a formula for the nth year. You can too, by the way, and then evaluated his formula for n equals to 5. Write Clarita's formula for the nth year and use it to find the account balance after the end of year 5. Okay, so we already have the correct answer of how much money should be in there. Oops, sorry. How much money should be in there. Thank you. It's this $488.65-ish. And depending on how you round, the banks will chop money off, the banks will round money. It depends on what your bank does. So this will either be 66 or 65 cents, right? We already have the correct answer. We now want a formula. So I looked and peeked through some of your formulas and I liked what I saw here. This is your formula. So if you were wondering, okay, where did they get all these numbers? Where did they get this $382.88 from? Where did that come from? Where did $382.88, where did that come from? Yes, very good. This was how much they started with, right? That's how much money that they kind of started with. Someone said, this is the y-intercept, Miss Johnson. Exactly. Someone else said, Miss Johnson, this is their starting amount. Exactly. So is everybody comfortable with this? Okay. Our friend just told us where this 1.05 came from. You guys all remember where that came from? Yes. And where does this, why is the 5 up here? Why is the 5 up here? Why is it an exponent? Why isn't it plus 5? Yeah. So this goes back to how Carlos calculated $488.6595, right? Yeah, it is geometric. Very good. And when your classmate says this is geometric, she's basically saying, hey, Miss Johnson, I'm multiplying by, multiplying by, multiplying by. So if I wanted to come up with a calculator expression for this, I would have gone like this: 382.88 times 1.05. That's how much money is in the second year, times 1.05. That's how much money is going to be in the third year, times 1.05. That's how much money is going to be in the fourth year, or at the beginning of the fourth year. Sorry, I'm saying the wrong thing. That's how much money is at the end of the fourth year. And then this is going to be how much money is in there at the end of the fifth year. Now, Miss Johnson, this is so annoying. Do you remember how I always do this? Like, oh my gosh, look how many times I had to write this. I wish that someone would tell me a faster way of writing this. And then this person says, I got you, Miss Johnson, I got you. This is how you write it faster. I write it with an exponent, right? I write it with an exponent. Ms. Johnson, why would you write it with an exponent? I mean, you don't have to write it with an exponent. I'm going to write it with an exponent because look, it's much more efficient than writing. Imagine this person writing this and, annotation on a computer, it's not the fanciest. So 382.88 times 1.05 times 1.05 times 1.05 still got you that amount of money that we said earlier, right? Very good. Next part, Carlos was surprised that Clarita's formula gave the same account balance as his year-by-year strategy. Explain in a way that would convince Carlos why it is so. And we talked about this already, so I'm just going to kind of move on. Okay, so next, are we all following? Are we all feeling good about this? Yes, very good. So Carlos says, I can't remember how much money we earned that summer. Says Carlos, I wonder if we can figure out how much we deposited in the account 5 years ago, knowing the account balance now. 5 years ago. 5 years ago. So the answer is yes, Carlos, we could do this. And so Carlos continued to use his strategy to extend his table year by year back 5 years. So notice he's going to be doing this thing, right? He's going backwards. Explain what you think Carlos is doing to find his table 1 year at a time, continuing filling it in. Yes, ma'am. Someone says, hey, Ms. Johnson, so now we're going to be dividing? Yes, ma'am. So exactly for this part here, very fantastic, by the way. So here, Carlos is going to be dividing. And let me see, I think some of you actually did that work for me. Very good. But no one actually showed it. So yeah, someone needs to put that down so that we all have this. So now we would divide. So here where am I here? This one. So now, so instead here, and so now, and remember, we talked about this. We talked about negative exponents, what they actually mean. It actually means powers of division, right? We're dividing. No, you cannot multiply by 0.5 because that would be, I'm cutting it in half, right? And then you could actually check. Someone asked a really good question. Ms. Johnson, if I went backwards and divided, I'll do this on the calculator so you guys can all see what I'm talking about. Someone said, hey, Ms. Johnson, I'm just using this person's. Couldn't we just divide by 0.5? So here's $364.65. And if you divide it by 0.05, right? That's $7,293. So I'm going to type in 7,000. Does that make sense? Look at these numbers. $7,293. Does that make sense for an account to go from $7,293 1 year, and then it drops $364.65. Does that make sense? And everyone's like, I mean, did you spend some money, Miss Johnson? What happened? And the answer is no, because Carlos and Clarita were just letting the money sit in there, right? It was just sitting in there waiting for us to use it when they became 20 years old. So I like the idea of dividing by 0.05. I understand where you're getting that from, but watch what happens when I divide by 1.05. Does that number make a little bit more sense than this number here, 347.29 cents? Did I type it wrong? I did. 347. Yeah, there you go. Yeah, this makes way more sense, right? So this is when they left and they want to know, go backwards. And you know what's going to happen on the next slide, right? You guys already saw it, but you guys all filled this out already. So I'm not going to, I'm just going to borrow someone else's. And I guess I should be snipping these. Let's see. Did we do this correctly? So 364.65 divided by 1.05. Good. And then again, instead of doing this, I'm just going to check this way. 0.05. And some of you are like, man, Ms. Johnson, you could do this a faster way. I know. I just want to check every single one. So here, I have the right answer, so I'm just gonna grab this and make sure that you guys all have access to it on our notes. So that is here. You guys are doing fantastic. So it's right there for you. Okay. So now we're going to move on to the next one. You guys did great. Okay. So this is where I lost some people because I know you guys were all working on this and I want to make sure that we get through this and then this all will make sense. Okay. So Clarita evaluated her formula again. So she did it again. She's using that same formula, except for now she's doing -5. Okay. She's now doing -5. And let's see, where are you guys at? There you go. And we don't have yet. So can you guys do me a favor? I'm going to pause the video really quick. Can you all do me a favor? Can you go back here and go back to your formula? So if you don't remember the formula, go to this one, I think. And here's my friend. My friend has this formula. So here, instead of taking it to the 5th for that new one, what are we going to take it to? Okay, so go ahead and I'm going to let you guys work on that together right now. Okay, so what we were supposed to do was you were supposed to take this formula from my buddy over here, the $382.88, and multiply it, just the same formula from Clarita's formula, right? But instead of here putting a +5, right? In this problem over here, yeah, you're supposed to use this -5 here, right? And what number did you all get? Let's see. Someone said $299.99. I don't know. You guys, we could have checked that from right here, our previous one. And that's what you guys got, $299.99. So now we're checking Clarita's formula. Okay, not this one. Where did that go? Here. This one, right? And so I'm just going to plug it in. Just, oh, wait, we did it. Look, to the -5th. She did, whoever this person is, sorry, Erica Walker. Not sure if you're a male or female. There you go. So this is how they got it. This is perfect. So I should be able to point to any part of this equation and be like, boom, Ms. Johnson, this is what it means. So let's just review really quick, right? Let's review. Where did this $382.88 come from again? Yeah, that's how much she started with, or that's how much they looked at the account at that certain point. And they're calling that day 0. Okay. So that's very typical of what we're looking at. That's when they're like counting or evaluating from. Does that make sense? Good. Where does this 1.05 come from? Where does this 1.05 come from? Very good. And someone says, Ms. Johnson, that's the interest because it's 5% interest. And then I'm going to say, okay, but where's the 1 coming from? If it's 5% interest, y'all, where'd the 1 come from? Where'd the 1 come from? Very good. It's the amount added. Very good. So you have to take what you already had. I'm kind of getting chills. You guys are doing so well. The original amount, which is the 1, because that's like 100%, right? Plus the 5%. Okay, then where's this -5 coming from? What the heck is this -5 mean? What does the -5 mean? Yes, because the question was, and I have to go back to here, how many they started with 5 years ago before they, when they first started the account, right? So this $382 is when maybe they left. And then going back 5 years, this is how much they put into the account. They didn't put any money in the account, so which is why we have $299.99. That's what they started with. Does that make sense? So if you think about it, it's kind of weird to think about this being 5 years ago, but -5 in terms of years makes sense. Like, what would be your, how old were you 5 years ago? You would subtract 5 from your age, correct? Yeah. Oh my gosh, how cute. Oh, 10-year-old yous. Oh my gosh, can't even. I'm not even going to go there. Okay. Next problem. Clarita said, okay, we did this one. This one says Clarita doesn't think leaving the money in the bank for another 5 years is such a great idea and suggests they invest the money in their next summer business. Dun, dun, dun. We'll have some startup costs and then this will pay for them without having to withdraw money from our other accounts. Carlos remarked, but we'll be withdrawing our money halfway through the year. Do you think we'll lose on this year's interest? No, they'll just pay us a half portion of the year's interest, replied Clarita. How much will that be? Okay, so a half a year's interest, what does that actually look like, right? So if 1 year was 4 and the next year was 5, remember we talked about this, like the in-betweeners. Do you guys remember that one? Can we calculate something that's in between, right? Discrete or continuous? And the answer is yes, right? So we went to this one. It says calculate the balance and how much interest you think Carlos and Clarita should be paid if they withdraw money half a year from now. Half a year from now. Remember, they currently have $382.88 in the account and that they earn 5% annually. Describe your strategy. Okay. So let me take a peek. Not yet, huh? I didn't think so. So right now, what I'd like you to do is I'd like you to take the equation that you came up with here in this one. Let me show you your guys' equation here. But instead of plugging in -5, what are we now going to be plugging in here? Very good, very good. We will be plugging in half because we want to know how much a half years of interest would be. A half years of interest would be. Very good. Okay, but yeah, that's fine. Oh, the equation was right here. What was I thinking? It's right here, guys. Okay, let me pause again. Okay, so as you were looking, you were filling all this out, right? And so when they wanted to figure out what half a year would look like. And so you guys plugged into the same equation and you just plugged in half. So do you see how you're doing the same thing over and over again, except for now you're plugging in different numbers based on what they're asking you to do, right? So earlier we plugged in -5 because we wanted to know 5 years ago. Here we're plugging in half because we want to know if we, pull it out in half of a year, right, for the summer. So this is how this person calculated it. They got 382.88 cents times 1.05 to the half. Let's see what that is. 382.88 times 1.05 to the 0.5, and they got $392.36. 34 cents, sorry. 34 cents. So that kind of makes sense, right? Because I didn't let it sit there for a full year, so it wouldn't accumulate as much had I let it. Does that make sense? So here's your answer. So $392.34. Everybody comfortable with this? I saw some of your answers. They look really good. Plugging in your 0.5. If you don't understand why we're plugging in 0.5, it's because they told us to. They told us right here, half a year from now. So your half a year needs to go in the half a year, the year spot, which is right here. It's your N, right? Very good. Okay, so let's move on. So this next question says, Carlos had some questions about Clarita's strategy. Oh, no. Yeah, so your percentage stays the same. That's a good question. Someone put, Ms. Johnson, I thought I was supposed to cut the interest rate in half. No, you cut the time in half, right? So when we're looking at this equation here, this is the money spot. This is kind of like the interest spot. And this is the year spot. So it's almost like you're putting people or things or numbers in the correct spot. This is like, like when you guys were younger and you looked at that, like that one puzzle and it was like, it had a square and then you were supposed to put the square inside of it and the star and you're supposed to put the star inside of it. Do you guys remember this? That little toy. Do you guys all remember that? Yes. Okay. So all you're doing is you're just putting the square in the square spot. You can't take the square, so in this case, the 5% annually, and switch it around. Yeah. You can't switch it around because that is the interest spot. That's where he goes. Does that make sense? You can't put the interest in the year spot because that's the year spot. Does that make sense? It's like putting your right shoe on your left foot and thinking, yeah, this is going to work. No, it's not. Okay. So does that make sense? Very good. Very, very good. Okay. So this one says Carlos had some questions. So what numerical amount do we multiply by when we use 1.05 as half to the half as a factor? So what number does that represent? What number is 1.05 to the 1/2? What number is, what does that number mean? Do you guys remember what we talked about last time with the half exponent? Yes. I'll give you a clue. Let's do 9 to the 1/2. It gives me 3. What is this 1/2 doing to your 9? What is that 1/2 doing to your 9? Yes, it's a square root. So this answer here, what numerical amount do we multiply by when we use 1.05 as a factor? Well, it's just the square root of 1.05, which is 1.02 something. Okay. What happens if we multiply 1.05 to the half and then multiply that result by 1.05 to the half again? Shouldn't that be a full year's worth of interest? I don't know. Let's try. So what was it? 388, no, 382.88. Is that right? Hold on a second. Need to go back here. 382.88. Okay. So here's my function. They asked if we did it twice, would we get the same amount? So let's do that. Versus, oh, I should just copy this. Except put this to the 1. So look at this. You guys all looking? So are these two numbers the same? And someone's like, no, Miss Johnson, they're not the same. Yeah. So how come they're not the same? If you took a half a year and you took a half a year, wouldn't that be the same? Right? And someone says, no, Miss Johnson, why aren't they the same? Someone explain to me why they aren't the same. Yeah. Okay. Okay. So hold on this question. If multiplying 1.05 to the half and 1.05 to the half is the same as multiplying by 1.05, what does that suggest about the value of 1.0 to the 1/2? And you guys already answered that, right? This means it's the square root. Okay. Okay. I'm going to have you guys hold on to this one real quick. All right. As Carlos is reflecting on the work, clear to notice is the date on the bank statement that started this whole conversation. This bank statement is 3 months old, she explained. That means the bank will owe us 3/4 of a year's interest. So how much interest will the bank owe us then? So find as many ways as you can to answer Carlos' question. How much will their account be worth in 3/4 of a year, 9 months, if it earns 5% interest? Okay, so now what are we doing? Like, what are we going to do with this formula now? Oh my gosh, you're so funny. So we're going to take that same formula, right? And what are we plugging in now? Yes, very good, very good, very good. We are now going to use that same formula, except for now we're going to plug in 3/4. Does that make sense? We're going to plug in 3/4. Very good, very good. Okay, so this is where I'm going to pause our video. I want you to plug in 3/4, and then we'll meet back to finish the rest of these to make sure that you guys are all set. Okay. Let's see.